Hey, my name's Anthony Green. I'm a solutions architect at Red Hat. I'm based in Toronto, and I work with the Canadian banks up there, and I see some of them represented in the room today, so thank you very much for coming.
I'm Josh West. I'm a middleware solution architect for Red Hat. I focus on everything from the developer perspective. I'm based out of the New York City area. I've been here almost 10 years, covering many of these large banks as a consultant, as an architect as well.
So I'm going to start things off. I've actually been with Red Hat for over 20 years now, very long time. Certainly going back to well before we were an enterprise software company, back to the days when you would go and get Red Hat Linux from CompUSA or Best Buy or get it in a book in Barnes & Noble. So we've grown quite a bit since then, obviously. We provide, and we're more than just a Linux company, right? We have obviously the Red Hat Enterprise Linux, but we've grown into middleware, we've grown into storage, we've grown into management solutions, development tools, all kinds of different areas. But I would say that if I look back over those 20 years, that no other technology has really done two things. One, captured the imagination of people in IT, or had that broad appeal across IT operations and development the way Linux containers has. So I'm very happy to be here talking to you about containers. Thanks for coming. And here's some of the agenda that we'll be covering today. So first, we're going to level set on what containers are, Linux containers. I mean, I'm sure many of you are familiar with them. Many of you are using them. I know some of you are using them in production already today. We did a bunch of work next with some research groups to ask our customers questions about their use of containers, what they're hoping to get out of it, and the challenges they see with containers. And so we summarized those challenges, and I'm going to explain today what Red Hat is doing to address those challenges for adoption. Thirdly, I'm going to do a little bit of a deep dive into Kubernetes. Linux containers in the enterprise, it's more than just Docker, the Docker tooling. You need additional tools to make an enterprise-ready container infrastructure, and Kubernetes is a key part of it from Red Hat's perspective. So we'll dig in a bit into the weeds with Kubernetes there. I'm going to hand it over to, actually, we'll do a demo then. We have an interesting demo with some prizes. I hope you'll participate in that. Then Josh is going to speak a little bit about some real-world container use cases, especially in the financial services industry where you all come from. And finally, we'll wrap it up with some information around how we're weaving support for container technology throughout all of our products. Like I said, there's a lot of interest in container technology, and we're reflecting that by building in support for containers throughout pretty much the entire portfolio. So after that, as John said, I hope you join us out in the foyer, as we say in Canada, and for a couple of beverages, and I'll be happy to talk to you further. So just to level set on what containers are. When we talk about containers, there are really two things we're talking about. One would be the packaging, the application packaging format for wrapping up applications in this in a format that's easily distributable within your infrastructure. And the second part of it is the runtime element of it. How are you going to run that process in some kind of contained environment? So we'll cover off the packaging format first. Since you're probably all Red Hat Enterprise Linux customers, I hope that many of you are familiar with RPMs. So the analogy I would like to draw in this case would be between a Docker container image and an RPM. They're both packaging formats for distributing applications, but they differ in one key area. With an RPM, you take your application, you wrap it up with some metadata, so you can distribute it and install it in your systems. And that metadata includes a description of all the dependencies for that application. Okay, so you've got your application in the middle, and then on the outside you say, I need this version of glibc, I need this version of this or that or the other, right? And before you can use that application, you have to install it. And the installation process involves dependency resolutions on the dependencies described in that RPM. And you pull in your version of glibc and Apache or whatever it is your application needs before you can run it. With containers, on the other hand, what we're doing is we're taking the application and we're still wrapping it up in a format that's easily shippable and distributable within your infrastructure. But instead of describing the dependencies on the outside of the container, we're building all the dependencies within the container. And so you end up with something that you don't necessarily have to install. There's no dependency resolution that happens at installation time to run it. You just ship it around and you run it. And everything that the application requires is within the container. Okay, so we have our host operating system and the containers with our application and all the libraries that they need and application data and so on and so forth. So that's the packaging side of things. On the runtime side of things, of course, containers provide a kind of isolation for processes, right? And we do this through leveraging technologies that we've been shipping in RHEL for many years now, including C groups, so that the application within the container only sees the resources that it has access to, namely memory or CPU or things like that. Kernel namespaces, so we can make sure that the process within the container could only see for instance, the NICs that it's supposed to. And we're introducing user namespaces. I'll talk a little bit about that later on. Additionally, we've got the security elements to it, SELinux, SVIRT, to make sure that the bits that are running inside the container aren't able to necessarily reach outside of the container and impact other processes running on your system. And then, of course, the Docker tooling. So as John mentioned, this is relatively new to RHEL. We've been shipping the Docker tools and related ecosystem tools like the Docker registry and Kubernetes in RHEL 7 for the past while. Any questions? Okay, pretty basic stuff. We're just level setting here. But again, just to wrap it up, in the old world, we had our host operating system, and if you wanted to create a multi-tenanted environment, or at least an environment where you're running multiple services on there, you have your application A, your application B, the libraries they depend on, they're all installed on the same host. If you needed to update application A, and it brought in new versions of the libraries it depended on, that's all great. However, what happens if those libraries conflict? The newer version of the library you depend on conflicts with the version that application B depends on. So that's what containers, one of the issues containers solves. By bundling in the application with all of its dependent libraries in a format that's easily redistributable within your environment, where these containers can easily co-reside on a single host, you've done something very important here, right? You've essentially decoupled the life cycle for your application and all its dependencies from the life cycle of your host operating system, right? Allowing you to have different life cycles for those different environments.
And what's really important on that point from a development perspective is that you're changing that line of collaboration between your operations team and your development team. So instead of giving someone a virtual machine, allowing them to change it, you're actually allowing the developer to create some sort of image that can just be deployed like it's something that's very, very generic. So really, it's disruptive to the model between the dev and ops that we're used to traditionally that actually made things a lot slower.
So we did some work with Forrester, a research company, and asked a number of our customers a series of questions, and I'm going to share some of the results with you today. So this question is, how important are the following container benefits to your organization, right? So number one by far was greater application portability. And this is really one of the great promises of Docker and the container ecosystem. And when I talk to my customers, the banks in Canada, and look at what they're doing, this is definitely pretty much the number one use case they have. They're building out these hybrid cloud environments where they have data centers on-premise, they have managed data centers, they have public cloud resources they want to take advantage of. And in order to do that, they want to build a fabric for supporting containers across all of those infrastructures and deploy and manage their applications as container images across those different infrastructures. I won't go deeply into these other ones, but of course, delivering and deploying applications faster, I would say that what you'll find, along with the rise of containers as a technology in the Linux world, you're seeing a rise in agile methodologies and the DevOps process. And I would say that while DevOps certainly doesn't require container technology, it does require some kind of programmable infrastructure. And Docker and related tools provide that to users. And so by adopting these newer processes, people are feeling they're getting better quality releases. So another question, the second question here, what are the top 3 quantifiable benefits your firm has realized from the use of containers? Like I said earlier, at least in my patch with the banks I work with, they're all on this journey adopting container technology, and some of them actually have workloads in production today. So this is not just development, this is production we're seeing. So higher quality releases, better application scalability, better support for microservices, which is really, I think container technology is really the preferred method for deploying microservice-based applications, where we're breaking up, monolithic apps into multiple services that all can talk to each other over loosely coupled APIs across, some kind of cloud infrastructure. So now with that out of the way, let's talk again about why containers are new and cool, because they're not really new, right? So many of you who've been around for a while may be familiar with Solaris zones, or in Red Hat Enterprise Linux, we've supported containers back in RHEL 6 with LXC. So that's 16 years ago, I guess, in 2010. So the underlying technology isn't really new, but there have been some developments, I'm sure you're all aware of, that have made them cool. And let's talk about the Docker tools for a second. So if we're talking about application packaging, we're going to talk first of all about the most interesting and popular program in the world, and that's Hello World. So here we have, it might be a little hard to read, here we have 4 implementations of Hello World written in different languages, here in C, Java, Node, and I think this is, Perl and PHP. So what Docker gives you is that easy way to package up these different applications into a common format that can easily run across your disparate infrastructure, physical, virtual, cloud, and so on and so forth. And again, it does that by packaging. We'll come back to this picture later, but it does that by packaging up all the dependencies within the container. It doesn't matter down here. The people who are managing this infrastructure and managing these applications running in production on this infrastructure, they just run the container. They don't necessarily have to know, at least to run it, what's inside it. So with our Java, we've got our JRE, we've got Node, we've got libv8, the JavaScript engine for Node. We've got Perl and PHP over here. They all have glibc. But like I said, it doesn't really matter. When you're looking at the container from the outside, it's just an application that's packaged in a container format that you can move around the same as any other, not really worrying about what's on the host platform. And you run, you start and stop and do all that the same way, regardless of the contents. So we'll talk about a typical experience for a developer. And I'm sure if any of you have hands up if you've had hands-on Docker experience. You've done like a Docker run Node.js. Okay, so a bunch of you. It's pretty cool. Like if you haven't done it before, you can try it out sometime. On a RHEL 7 box, you just basically type in Docker run, the name of your container. It'll go and fetch that from somewhere, and boom, you've got Node.js up and running. It is almost a magical experience for developers out there. Not having to worry about installing on my host. Oh, geez, I don't have permissions to install Node on my host. I don't have, I've got this incompatible stuff there. How am I going to reproduce it? It is essentially a magical process of just running a simple command line and having something up and running. Most people think, wow, that was super exciting and super easy. Let's let's follow that up by Dockerizing our entire data center, right? We have all these services that are running on different servers out there. Maybe we can package them up into containers and deploy them and realize the benefits of Docker throughout the data center. But as people who attempt this in the early days, what they quickly realize is that it's not easy necessarily to go from a single Docker image or server running on a laptop to running multi-container services in an enterprise environment, right? There's some steps in the middle. You need more than just Docker. You need additional tooling to provide security, high availability, and so on and so forth. So we asked customers, what are the top 3 challenges the organizations have experienced using containers? Number 1, by far, is security. So Actually, more than 50% of the people put security as their number one concern. But we'll go down the list. Security, performance. Am I going to get the same performance running my applications in Docker that I do running on bare metal? Integration with development tools and processes. Do those integrations exist? Are they supported? Lack of certification. So if you think back to when virtualization was introduced into in a big way into IT a while back, the question is, geez, well, that's great. My ISV supports this application running on bare metal. Are they going to support it running in a VMware? And so those same kind of questions are coming up now around Docker tools and Linux containers. And finally, management. And so I'm just going to go through these 5 and explain where Red Hat is and what we're doing to address these 5 concerns. So we'll start with security. So if you remember this picture, we had our different applications running in containers, all bundling up their own version of glibc, for instance, right? It's a fundamentally critical element fundamental critical element of pretty much anything that's running on Linux these days. These numbers, I'm not sure if you can read them, in the triangles here. So beside glibc, we have 6. Beside libssl, 29. PHP 29, JRE 66. These are the number of critical, important, and moderate vulnerabilities that have been identified and fixed by RHEL in the first 300 or so days of RHEL 7.0. If you can imagine an environment where you've got maybe 4 hosts and you're running 100 containers, or 4 hosts with 100 services, and in the old days, if there was a glibc vulnerability, you'd be out there patching 4 glibcs or updating 4 glibcs. Now in this new world, you have 100 containers running across 4 servers. That's 104 glibcs that you have to worry about monitoring and patching and making sure they're secure. This is actually a little bit, I guess about a year ago, a company called Banyan Ops did an analysis of all of the Docker images that are hosted in Docker Hub. So if you're not familiar with Docker Hub is a public registry where just about anyone can go and push a Docker image to share with the rest of the community out there. And this analysis is done just on what they call the official Docker images, right? So these are images provided by ISVs to support their applications that they've got out there. So I don't know, MongoDB or so on and so forth. So what they discovered was that 36 of the images that you could get from Docker Hub included some kind of high priority CVE that was unaddressed, right? And 28, so over 60%, that 28 with medium priority, so over 60% for sure, had some kind of serious vulnerability that required patching. So it's important that you really understand what's inside your Docker container when you're running it. And this is really why people in operations kind of freak out when you start talking to them about introducing containers in the infrastructure. At Red Hat, when we think about container security, there are really 4 things that we need to address. One is, I guess starting in the middle, are the sources trusted, right? What's the provenance of this image that you're going to run in your environment? When you run a Docker container, essentially on your host, it's almost like you're giving that application is running as root on the host. So you want to make sure that the images that you're running are coming from trusted sources. Have they been modified? Is there some kind of audit trail that takes you back to the source of the bits, and are they a trusted provider? Once you've realized, okay, I've got trusted bits, well, then you need to look inside the container and make sure that everything is okay. Are there CVEs that need to be addressed? Vulnerabilities, right? Have things been configured in a way that's appropriate for your infrastructure? Am I okay from that perspective? And even when I say, yeah, okay, trusted source, the bits are all okay, no vulnerabilities, really that's just a point in time view. Things change over time, CVEs come out. You need to have a way to continually inspect those containers to make sure things are okay, like a policy-driven inspection process to monitor the environment and make sure you address issues as they arise. And finally, the isolation of hosts. So it's, one analogy people sometimes make, which isn't true, is that An application inside a container is like money inside an armored vehicle. Then it's not like that at all. It's more like, money inside a cotton bag or something like that. So the isolation, think of the container as really something holding bits and not necessarily providing additional security. Now, security is all about layers, obviously, right? And so you do get some additional security by adding this thin layer of container and isolation of the host from the contents of the container and containers from one another. But it's still a concern, and Red Hat's doing a lot of work in this area. On your desks, you probably have, hopefully you have a copy of the container coloring book. It's a follow-up to our very popular SE Linux coloring book. Both of them are available on the web. I think the Container Security Guide coloring book does a pretty good job of explaining the different choices you have and the choices that we're making around, around container security and host isolation. Actually, I would strongly recommend having a look at the SE Linux coloring book as well, because it does a great job of simplifying how SE Linux works in these environments. And really running a container without SE Linux enabled is something that we strongly advise that you don't do. When it comes to provenance, Red Hat has a container security program, certification program in place. So when we launched RHEL 7, right, including the Docker tools and the registry and so on, we also launched a hosted registry at Red Hat where you can get base images from which you build your containerized apps for RHEL 7, RHEL 6, and plus those and additional bits to support, Apache, various databases, some profiling monitoring tools, and a lot of the programming languages and frameworks that we ship within the software collections world, so things like Node.js and so on. These are base images that you are free to go and build upon. We update them regularly as CVEs get addressed and provide new versions to our customers. As far as scanning is concerned, hopefully some of you have heard of the OpenSCAP tooling, or OpenSCAP, some people call it. So this is a project that we developed with the federal government here in the US and some government agencies to provide configuration management scanning capabilities. So we work with customers who basically say, okay, we have we have our RHEL system, we have all these text files that we've edited to enable certain features or configure things in a certain way. What we would like is so maybe to conform to their PCI DSS regulations or some other regulatory prescriptive documents they need to follow. And OpenSCAP allows you to generate some content that it will use to scan your system to make sure the system complies to the standards that you've set forth, right? So if you say, okay, well, on this system, these users exist and they have to have these user IDs and these directories can exist, and if these files exist, then they need to have these permissions and so on and so forth. So OpenSCAP is something you can use to enforce those standards on your servers. What we've been doing, though, is adding capabilities to OpenSCAP and related tools to allow you to scan container images. Okay, so not only can you scan an online image that's running, right, for your configuration policy, but also offline images. So you don't have to be running these things. You can go into a Docker registry and say, scan all these container images based on the policy that I'm specifying here. And it's not just policy that I've described before, but it's also CVE definitions. So we publish on our website and regularly update a mapping of CVEs to RPM versions, right? So glibc version blah, blah, blah is vulnerable to this set of CVEs. So with that mapping in place, the Docker OSCAP tool can then look inside that Docker image and identify any issues that need to be addressed by updating the packages that we ship. So this is something really when you think about building out some kind of pipeline for generating Docker images based on your applications, you can kind of inject that in the pipeline process and ensure that things are getting deployed that have been scanned and trusted they're based on certified bits. Finally, really when it comes to security, I mentioned earlier that some people have maybe a false impression that Docker introduces additional security layers. It's really not necessarily the case. And what I encourage everyone to do is to not drop or not forget about the best practices they've established for deploying workloads on servers when they move to container images. So for instance, if you're running a service as a non-root user on a server, don't just run it as root in the container. Create that service user within the container image and run it in the container that way. Okay, so let's move on to performance. There are many, many things that can impact the performance of workloads running within containers. These are just a few. Certainly how you map storage into the container has something to do with it. How you hook up your networking, your NICs and your networks to the container image has something to do with it. Control groups, like you mentioned, certainly has something to do with it. And of course, Linux. It provides so many knobs and sliders and things to tweak that there are literally hundreds of things that you can modify to impact performance for just about any workload, not just containers. But how can you wrap this up in a way that's easy to use? And we do that at Red Hat with something called TuneD. So we provide profiles, essentially, that describe workloads running on the host. And within those profiles, various knobs and sliders and things are set based on those workloads to give as best as we can perform the best performance for that workload on the host. You can imagine a hierarchy of these tuning profiles. So we'll go through maybe you've got a latency performance profile that modifies maybe the packet size on your networks, and underneath that that would be in the network latency profile, and underneath that you've got maybe some middleware profile for a specific workload, where we're describing how the system needs to be tuned to support this middleware workload as best as possible. TuneD is a service that basically runs when the server starts up, and it applies whatever profile you've selected for that host to the running system to get the performance you need. We ship out of the box with a number of different profiles. We've got a desktop profile for low latency, desktop work. We have a virtual host, virtual guest. In the virtual guest, for instance, you don't want to schedule I/O in the guest. So there are a number of them, and most relevant to what we're talking about now is we have these rel atomic profiles, so atomic host and atomic guest. And I haven't mentioned it yet, but atomic is really this umbrella term that we're using to describe some of the work we're doing in the container space. So atomic host is the atomic host at Red Hat is really a purpose-built version of rel, right, for hosting Docker images, right? So it doesn't have all the extra stuff you would normally find on a rel server. It's kind of a trimmed down version of rel 7 that has some interesting features as it relates to hosting containers. But it comes tuned out of the box to handle most workloads. And then there's an atomic guest profile as well. So you can definitely check out TuneD. And when we look at benchmarks, here's a typical database benchmark using the Sysbench standard benchmark results. And we're seeing about a 1.5 to 3% performance hit running bare metal versus in a containerized environment. So not too bad. When we look at network latencies, there is a small overhead and network latencies around 2 milliseconds for this particular case. And that's generally because we're introducing a software network overlay when we're running containerized applications under Docker and Kubernetes. So there's a longer path for the packets to follow.
So basically what I'm hearing is if you have a bunch of performance settings on your bare metal environment, and say you have a bunch of cohabitating applications, really what you're going to do is put each one of those applications now in its own Docker image and bump your performance tuning profiles down to view the Docker image rather than the application itself. Basically, you're tuning the way the image takes control of the bare metal resources.
Yeah, there's a little bit.
Interpreting it properly? I mean, do the tunings ever reside in the container anymore, or are they for the container? I guess that's my question.
The important ones are for the host, okay? Because they're generally, we're talking about kernel tunings.
Exactly.
Right? And so it's a shared kernel across. So what you want to do is make sure that, ideally, workloads with similar performance profiles co-reside on a similar host, right? And we have the tools to allow that with Kubernetes and where you can do intelligent scheduling and placement of workloads within your clusters.
You got it. Okay. I think that kind of is what he was asking as well, but I think in the couple of slides later, you made it clearer.
Okay.
Yeah, I just wanted to verify.
Yeah.
Yeah, you mentioned that containers would have a longer path for packets to follow. How about in the case when you have set up kernel bypass, RDMA, Solar Flare, open onload?
So there is an option where you can map NICs from the host directly into the container image, but you're kind of limiting yourself in terms of what the overarching orchestration tool can do for workload placement and things like that. It's possible, but you don't have to. You can bypass the overlay network, is what I'm saying. Integration, and I'm going to talk about developer integration right now, since a lot of what we talk about around containers applies to developers. So we have OpenShift. Hopefully, a lot of you have heard of this. It was originally envisioned as a PaaS to provide self-service for developers for access to lots of different programming environments, and allow them to easily provision, build and provision applications within a container cluster of sorts. And so OpenShift really is, to give a little bit of history, it's been around for a few years now. In its prior incarnation, it was also based on container technology, the LXC that I mentioned earlier, and related tools that we shipped in RHEL 6. We pivoted a while back, I guess maybe a little over a year ago now, with OpenShift version 3, where it's all based on Docker, it's all based on Kubernetes. Basically, we provide all the plumbing, Kubernetes, the registries, Docker, and everything, and OpenShift sits on top to integrate all that with the developer tooling, with underlying resources provided by your hosting environment, whether it's public cloud or OpenStack or some other infrastructure. And Josh is going to be giving a bit of a demo of that very soon. But if your developers are already using Docker and you want to look at OpenShift, OpenShift will consume their Docker files directly, right? The developer essentially commits a Docker file, it handles the build, it creates the image, and it will handle the deployment of that Docker image within your infrastructure. And that's part of what you'll see. One of the interesting things that we've included in OpenShift is this notion of source-to-image tooling. So while a lot of folks are familiar with Docker files and doing a Docker build and leveraging Jenkins to automate like a CI workflow to build these things, we have a very nice set of toolings built into the OpenShift environment where a developer can take their code, they commit it into some kind of, push it into some kind of Git repository, for instance. And then we have a build that's automated off that based on like webhooks from the Git environment, or maybe it's a manual process. It will take the source code, it takes a builder image for the framework that you're working on out of a registry that you maintain, combines the two and does the build, talking to your various repos to pull dependencies down and so forth. And then it will handle deployment. And it's not just very simple deployments, but it will handle very sophisticated kinds of deployments like rolling upgrades and so on. So you specify how many container images you need, what are the dependencies between them, and it will handle all of that rolling upgrades for you. One of the other nice things about it is that, I mentioned earlier, you have to constantly monitor that base image, right? Maybe this is a Node.js application. I'm using a Node base image that I'm going to use to generate my application. Well, what happens when Red Hat patches the glibc within that base image? Well, the OpenShift tooling will notice, there's an updated version in the registry, whether it's our registry or your own registry, depends how you have it hooked up, and it will go ahead and optionally rebuild all of the applications that are based on that base image and push them out into a registry, or optionally, again, redeploy them, do that rolling upgrade for you. So it can really gives you, if you wanted to, a process from a developer commit right into some kind of production or even QA or test environment in a fully automated manner. So challenge number 4, orchestration. So I've mentioned Kubernetes a few times. For those of you who aren't really familiar with Kubernetes, my high-level summary of Kubernetes is that it is a cluster manager for containers. Basically, you describe services which are built of a number of containers and describe how the containers depend on one another. And Kubernetes handles all the things like high availability and service discovery, right? If I have a service that has a web front end and an app server and a database, it'll make sure that they're all wired up together on the right network and the appropriate IPs are presented and the routes into that service are provided from the outside. It's a wonderful tool. It was essentially brought to market as an open source project by Google, who has a lot of experience in this area since everything that they do within Google is run in a container. All your Gmail search sessions, your searches run in containers. And they decided, as they built out their cloud environment, they wanted to make it easy for people to move workloads into that cloud. And so they thought, well, let's rebuild what we've built internally into a public project that people can leverage to make it easy for them to deploy and manage containers the same way we do. And that's what Kubernetes is. Red Hat is deeply invested in Kubernetes, as well as Docker. I believe we're the second largest contributor to both those projects and have been for some time now. But we have other tools. If we kind of walk through a journey that many organizations go through, we've got the developers sitting down at their desktop. They did that, Docker run Node.js and that fantastic success moment running their first application. Then maybe, hey, I've got multiple containers, like I said, the web front end and the app server and the database. They can leverage not only the atomic host or the atomic tools that we ship in RHEL, but Ansible. So Ansible is a very popular tool for orchestration, configuration management, and it can be very useful in helping build out these multi-container applications for a single developer. Then he gets his buddies on board and, hey, we're going to, now for our team, we're going to be running multiple containers and have multiple developers working. So I guess moving fast and breaking things is the term that lots of people talk about these days. But again, the basic tools that we provide from Red Hat allow you, will certainly get you to this stage and beyond. Then, okay, the developers have built all this great stuff. We want to move it into production. We talk to the operations people. Kubernetes is really what introduces all the operational aspects of supporting containerized, multi-container applications out in production, right? Again, high availability, and you'll see some of that in the demo. And of course, finally, this is almost like a container maturity process or model where we get to a point where, hey, geez, let's just leverage the OpenShift paths to manage all of this. Earlier, I talked about one of the most common use cases we have for containers, and that's customers who are building out these fabrics to support containerized apps across disparate infrastructures. They're on-premise data centers out to public cloud, Azure or AWS or Google. And we've been talking about this kind of deployment for a long time at Red Hat. We've been using the term open hybrid cloud to describe these hybrid cloud environments where we're using open source software and open standards to make it easy for customers to deploy and manage workloads anywhere, from physical to public cloud. And so to that end, we've really enhanced our portfolio to make it easy. Satellite, I'll talk a little bit later, but satellite these days, of course, supports all these different environments and actually now acts as an enterprise registry for Docker images. Right? CloudForms is our cloud management platform. In December, we launched the latest version that introduces support for talking to Kubernetes and OpenShift. It's giving you the ability to, from an operational perspective, look at the workloads that are running on my infrastructure and drill down from from the container to the host to the VM to the underlying infrastructure to give you that visibility all the way down the stack for performance, for monitoring, for policy management, all those kinds of things. And then the middleware, I'll talk about a little bit later, but we are packaging up everything that we ship pretty much from a middleware perspective and deploying it under this XPaaS umbrella, which essentially means the middleware is provided as a container image in a manner that takes advantage of the promise of containers by allowing auto scaling and auto clustering and things like that. The final one I'll talk about is certification. So I actually talked a bit about this already. So at Red Hat, we are certifying certainly the base images, right, and the hosts, where if you run these base images on these versions of RHEL, then we're going to, our SLA applies, right? You'll still get the 1 hour response time on the Set1 SLAs and the great support that you expect from Red Hat for that entire stack. Where it is kind of possible to run containers, and that's one of the great things about them. I can take, some other Linux distribution, distribution A container and run it on distribution B host. And the reason that's possible is because the dependencies between the container and the host are just the kernel system call interfaces, right, into the kernel. There's no other dependencies there. And those have been relatively stable for a long time. But we don't test every combination. The versions that we're testing and what we're certifying is the combinations that we're publishing on our website. So in addition to certification, standards are important, and certainly the format, the container format with Docker, we're 100% behind the Docker format these days. We're working with Microsoft and Docker Inc. To make sure that we're all kind of on the same path with the container format. Kubernetes we've selected as a de facto standard for cluster management, container management, given Oracle's involvement in the project and a terrific governance model they've introduced for that project. So we feel that it's something that we can work with, and we have been working with very successfully for some time now. The container registry, of course, there are standards around that. We provide the standard registry with RHEL. We provide the registry within OpenShift. We provide a registry within Satellite. And then the isolation, and this is really leveraging the de facto standards that are built into the Linux kernel around cgroups and SELinux and SVIRT and so on. Very quickly, we'll dig a little bit deeper into Kubernetes, if that's all right. Kubernetes is one of those things that it really is important to get familiar with and understand how it all works, because, like I said earlier, deploying standalone container applications is really not something that you want to try. But when we talk about Kubernetes, we talk about nodes. Okay, and these are hosts that are going to be running containerized applications. So that can be either Red Hat Enterprise Linux or the Atomic host, which I spoke of earlier. It doesn't really matter. And because it's RHEL, it runs anywhere RHEL runs. So we leverage the certifications that we have for the hardware partners and with all the cloud providers out there. These nodes run these containers, right, in something called a pod. And a pod is a concept that's introduced by Kubernetes, where we're talking about containers that work together, and they will co-reside on a single host, right? So they can talk to one another over localhost, for instance. You don't have to worry about any kind of SDN or anything like that. Generally, if they co-reside in a single pod, they're the kinds of things that you want to scale up and down together. Most workloads, when you see deployments using Kubernetes, it's generally a container per pod, but you can bundle them together. Of course, the registry is where we store all these container images. Kubernetes is able to talk to the registry we ship in OpenShift or some third-party one or the one in Satellite. So in addition to the nodes, we have these master nodes. So the masters are essentially where all the logic happens for Kubernetes, all the logic for orchestration and so on. So here are some of the things it provides. So certainly, I don't know if you can read this, certainly an API and user authentication. So it handles user authentication and authorization. So Kubernetes can hook into your IDM, your AD, your LDAP, what have you, to provide user authentication. So people who want to deploy workloads in Kubernetes have to authenticate. And then authorization, so essentially that's role-based access control for Kubernetes. The data store. So There are a number of, we use etcd in Kubernetes, so it's basically a key value store where we store metadata that's required by Kubernetes to manage the entire environment. We have a couple of masters here because while you can deploy a single one, in most cases people deploy 3 to 5 in a single cluster environment to provide the high availability. The scheduler. So this is where we handle workload placement. So when we were talking earlier about having containers co-reside on a single host where we've tuned that host for a certain kind of workload, that's what the scheduler handles. By default, it looks at things like network utilization and CPU load and things like that on the nodes as it deploys containers to those nodes, but it's completely programmable. So if you, for instance, needed to have a policy where you wanted you wanted an anti-affinity rule for a container, so these containers couldn't reside on the same host because you had some high availability concerns, then that's something that Kubernetes can handle for you. Then we have the service layer. So this is where basically we introduce like a software-defined overlay networking element for Kubernetes. So every pod or container within a service gets assigned its own private network, right? And so for instance, if these containers and these containers were all part of a single service managed by Kubernetes, they would land on their own private network. And Kubernetes also provides some service discovery mechanisms. So either, for instance, DNS, you can simply ask a DNS service provided by Kubernetes, where's my MySQL database, and it will give you the IP for that container. Or it has some magic with environment variables you can use as well for service discovery. But the point is that Kubernetes handles all of this for you. It also handles replication. So in many, many cases, while people are using containers to stand up, traditional enterprise, I don't know if you want to call them mode 1 workloads, scale-up workloads, the most common use case that was envisioned and we see in practice is these scale-out workloads where we want to replicate containers. We want 100 instances of this or 12 instances of that. And that's what Kubernetes handles as well. So it will make sure that the appropriate numbers of containers are running. What happens if a pod goes down? Well, Kubernetes will notice that and say, oh, geez, I had 12 of these running. I need 12 to be running, but I just noticed there are only 8. So it'll fire up the missing 4 on additional nodes and make you whole again. Finally, second to last, Kubernetes manages persistent storage. So Josh mentioned earlier that typically with these containers are ephemeral things. You don't generally rely on local storage. Originally envisioned as like these stateless workloads where there's no storage is ephemeral. There's no state allocated to them or stored in them. But for these traditional applications, you generally would want, like a MySQL database, you're going to want some persistent storage. So Kubernetes handles that by this very clever mechanism of storage claims that applications can make, and it will make sure that the storage follows the container around as it's shut down and brought up elsewhere. And we provide lots of plugins for different kinds of backend storage. So certainly, NFFs and CIFS and so on, but also Ceph and Gluster and the
Amazon, Google, Azure,
Amazon, Google,
as well. Yep.
All those things. So it's nice in that it gives you that isolation. The application guys don't really have to worry about what is the storage I'm going to attach to that's handled by operations.
And if you're familiar with other PaaS, that's actually fairly unique to the Docker and OpenShift ecosystem. Other PaaS don't allow you to have stateful services, and that kind of changes. This turns into more of a general compute platform rather than just a stateless microservices PaaS.
And then finally, we have the routing layer. And this is essentially the way that you get into your service from the outside world, following some URL or so on. So forth. Kubernetes, out of the box right now, we use a technology called HA proxy to provide that route from the outside world to the appropriate container on the appropriate node. But you can also use like an F5 load balancer. So there are plugins to Kubernetes to leverage other kinds of routers out there, and F5 is one of the options out there. So this is the basic Kubernetes picture. What OpenShift then gives you is that developer experience. So if you imagine Kubernetes and Docker and all that is the underlying plumbing, OpenShift adds this, the CI/CD pipeline, the integration with other management tools, performance monitoring, and all that. And I think we're going to move on to a fun demo. Yeah. So I'm going to hand it over to Josh.
All right, thanks. Yep, this is the interactive demo time. So hopefully Amazon's working for me and the internet's working fine as well. So what we're going to do is we're going to pretend we just wrote a Node.js application. We're going to deploy that to our OpenShift environment. We're going to have that automatically built into a Docker container. And then we're going to deploy it using Kubernetes. It's going to scale. We're going to also show that as we break it, it automatically heals as well. So first, we're in our OpenShift interface here. You can see I actually have a project called Demo, and I can add to this project, and we'll create a new Node.js application using our latest container. So we'll call this Sketchpod, and we have some code up here on GitHub, and this could be really any code address here. And we have the ability to change some of these advanced settings. So I'll give, for example, point to a specific branch that we just did. Maybe this is my own project, and I'm testing a new fix for it. We can change the routing, set the actual alias to the URL to the application, change some of the build settings or the automatic new build settings. So we can basically trigger new builds. All we're going to do here is set some of the labels, and labels are actually pretty powerful, allowing you to control where these things are placed or even how they're grouped to run scripts on them. All right, so we'll deploy this application, and OpenShift is taking this right away. It's allowing us to even download that code or interact with that code and push more changes to that. So if we come over here, we see that our Sketchpod application already has a URL. It's deploying this application, and we can watch over this build process. And this build process is actually taking that code, pulling it from GitHub, taking the base Node.js image, doing a build using all of those components that are basically pre-certified for my environment. And if we watch the end of this, we should see this is almost done. It's going to basically take this, is actually pushing that new application right to a Docker registry that we can then deploy into our environment. All right, all done. So if I watch over the environment here, you can see I have a lot of different settings here, but what I want to look is the pods. The pod is that deployment of the actual application. We're currently deploying this here. We'll see it's actually up and running already, and we can see the logs for the application. You can see it's a Node.js app, very basic, starting server.js. It's already listening on that port. We could also, for example, log into this container, start running some commands, maybe take a look at what's inside of this code, just to inspect it is what we want. So now this application is running, you'll see that if we have basically our keynote demo here, there's a bunch of hex boards. So this represents actually one process per little hex board. We've so far deployed one actual process or Docker container or pod in our entire environment. So imagine this is a cluster of, it's actually 4 nodes on Amazon, large nodes. This could be 100 different nodes. We're going to deploy many, many processes to this here. It was very easy to automatically deploy this new code to the environment. And then we could scale this up by simply going into OpenShift and increasing the number of pods here. So Kubernetes is pretty powerful, and you just say that here's a number of things that I want to be running, and it's going to try to make that state happen for you and keep that state going. So you can see that these processes, they start in this empty state, they're moving to a waiting, pending, running, live, and then it's responding to new requests. And Kubernetes is actually making sure that this process or this service is actually up and running, and then it's actually taking requests. So now all 10 of our processes are up and running. You can see it's starting to create this mosaic of Red Hat background. Now, if we were to kill some of these pods, let's say we came over here and said, let's kill 8 of these. You can see a bunch die, and then immediately it's starting to start up new pods elsewhere in that cluster. So we have a total of 10. So let's say this is a new web app. It's widely successful, and we want to show how it scales up to use all this space. So we're going to set it to 108 replicas. So it's going to start to take over this whole environment. we can have one of these processes for every possible container in this whole service. And you'll see this mosaic starts to fill in. If everyone can get out their mobile phones, we're actually going to have an interactive part of the session now as well, where you actually get to draw in here, and you actually kind of get your own process. When you draw a sketch on your mobile phone, you're going to see it shows up on the screen here as well. And based on who puts their things up there, we're going to randomly select 2 winners that win a couple of prizes here. So go to bit.ly/nysketch2016. Please do put in your name, other identifying information so we can make sure that we're getting to the right person. If you're a Red Hatter, go ahead and draw an image, but we're only going to give the prize to customers. Sorry, guys. Whoever wants the BB-8 here, little remote control device, and we also have a Chromecast as the second prize. So just to demonstrate, this is on my mobile device. I can draw something on here and then deploy that, and we should see that show up in the screen here. And hopefully some people have already started interacting here. Here we go. So we have several of these images showing up already. Cool, so go ahead and continue to fill that out. We'll do a drawing as we're finishing up the presentation once Anthony takes back over, but we can show back in the screen. We're going to see hopefully all of these tiles built up. And just remember, this represents an actual process on a server that you own yourself. And consider Gmail, for example, they actually have one process per Gmail account to hold that context and keep it going. And they'll make sure that state or that process is always running for you. This is similar in that nature, although this could be something generic. Or it's a generic process scaling up traditional web services or even batch jobs or something else. All right, so we just wanted to also discuss a little bit about what we're actually seeing in financial services for container adoption. As we mentioned, that containers have really only been available from RHEL 7. We've had OpenShift 3 available. We're still waiting for that day when everyone's is ubiquitous. We believe it's going to get there very soon. So in financial services, you always see people start where there's budget and also freedom from the governance teams to be able to do these new things. So there's some teams that need to do hybrid cloud bursting. We see this a lot in the grid space when people have to do a lot of work that they only have so much infrastructure. They want to be able to burst out the public cloud. These tools allow you to have the one process that's written, deploying the same to your on-premise enterprise as well as on the public cloud. So the capacity on demand is the big power here. Again, the ability to break out of the governance that you have from central IT, the very locked down processes you have. So that's where we've had the first interest in some of the successes. Another is from the vertical side, risk processing regulation. The regulations are changing so fast. Regulatory demands require a lot of compute, and that's scaling up over time. So things like liquidity risk processing, you actually need data across the entire enterprise. You need to slice and dice that data, marry it to a bunch of reference data, and you can never keep up with all the updates you have to make so quickly to meet these deadlines. So because of that complex compute, the need to test everything in various matrices, wrapping those workloads inside of containers allows you to very quickly deploy small pieces of that in isolation, test them in isolation, and hopefully deploy something much faster, removing all of the people running run books to get every server out or a new deployment out. Another side of that is regulation, making sure your systems are always current. There's hygiene. Many people have been stuck on very old versions of technologies. So OpenShift and containers allow you to basically define that you're using a certain technology and you're creating this pipeline of automatically updating your applications, performing builds, pushing out to an environment to do a UAT test without manual intervention at every step. So hopefully we're getting to a much more hygiene in financial services and current usage of the latest versions of technologies. With containers as an enabler of that. There's been cycles of every financial firm trying to provide, more accelerated innovation through platform as a service. So, again, like I mentioned in the beginning, this new mode of collaboration between developers and operations, you're basically freeing the developers to have full control over what they're creating. You're just giving them a registry of things they can start with, and they can go all the way to production as long as you have your final approvals on that setup. So it enables DevOps, Agile, CI/CD, new architectures like microservices, Although, like I mentioned before, we're not locking people into microservices, stateful applications only. You can still deploy your traditional, more end-tier applications. Maybe they're stateful on OpenShift or on our container platforms. But we also really push for and enable microservices as well. The other big piece is the open ecosystem and technology stack. Red Hat historically been represented openness, being open at every layer, so you get full choice of what you're going to actually run in your containers. And hopefully we're just providing help and certifying those, making sure that you're safe with whatever you choose. The last piece is trading and payment systems. So many of the people who are doing high performance computing, even things like derivatives trading, they've been very locked down to avoid things like virtualization, which allow you to much more quickly set up new machines, have a better life cycle, but that there's an overhead to virtualization that's slowly been taken out over time. But because you're using containers, you're kind of working right at the kernel. That could be right at the bare metal level. And so we're seeing some people that were trying to move to things like OpenStack, moving for these HPC workloads, moving right to containers instead. And then you also have this streamlined promotion. So before, when you had a lot of people who were very advanced scripters to deploy new deployments of these systems, now you can use containers to still create something in development, very, very quickly get it up to production through a standardized process. I think we have almost every image here taken. So just make sure everyone thinks this is fair. What we're going to do is we're going to select some random winners. The top left to right is what we're going to choose here. So here we go. Well, hopefully this will work if I hit random winners. All right. So whoever drew this one here, I think this got a little guy. That's the Shadow Man. Good, very good. And then the polka dot guy here also wins. All right. Well, thanks, guys. I guess I'll give it back to Anthony. He's going to talk more about our portfolio and how it maps into the environment here.
Where do you see Kubernetes' role here? Do you see Kubernetes more as just the orchestration manager for deploying the containers that are going to be part of a large cluster? Or do you see Kubernetes actually getting involved in the actual workload scheduling and distribution, which is different? Now that's getting into the application component. And I see there's some blurring of responsibilities, and I'm just curious, where do you see the division of labor?
Well, what we're going to see is Kubernetes is getting much more mature. Hopefully that whole question got on the mic. So Kubernetes in the latest version just added this new concept of jobs. So we'll be scheduling jobs throughout the environment. Think a batch job, but it would be a new process for each deployment of that. We are working, and there's actually some partners we have, like Blue Data. They're doing things like Hadoop on top of OpenShift or container platforms, where you might have a process that's available there for maybe a bunch of Hive nodes or a bunch of Hadoop nodes, and it's going to schedule, there's going to be some other scheduler that's doing the jobs within those individual JVMs or other processes. So I believe there could always be some sort of blur between separation of the actual task versus the process. But I think we're going to see Kubernetes take over much more of that space over time, and it's recently got to that level.
The container technology really came on very quickly, and Red Hat was on board very early on, and what you're seeing is introduction of support for containers in one form or another, pretty much throughout the entire portfolio of products. So I'm going to walk through some of the changes that are happening and some of the developments that you'll see from Red Hat. So first of all, we already had a quick look at OpenShift Enterprise. OpenShift is, like I said earlier, it was originally envisioned as a PaaS. People are using it more as a container management platform, essentially. But it gives you that developer self-service and additional functionality on top of the basic elements that are provided by Kubernetes and Docker and so forth. If you peel off that web UI, right, the self-service elements of it, then you get to something that we're calling Red Hat Atomic Enterprise Platform. So this is really, it's really a enterprise-ready distribution of Kubernetes plus Docker. So, another way to look at it is at the bottom where we have RHEL and Atomic Host. Like I said earlier, it's just a trimmed-down version of RHEL. In that distribution, you'll find the basic tools, but not the things like user authentication, authorization, some of the plugins for storage or networking. Those are really coming under Atomic Enterprise Platform and above. Atomic Enterprise Platform, I know some of you are using it right now. It is in a public beta form right now. We haven't really announced the productization or rollout plans of Autonomous Enterprise Platform, but that should be coming very soon. And this is essentially bundling OpenStack and related tools with OpenShift, because OpenStack is actually a great place on which to run OpenShift. Where OpenShift, you're essentially pre-allocating a certain number of VMs on which you're going to run a dynamic and elastic set of container images. If you need to grow that footprint of nodes, then OpenStack provides a great platform for doing that on-premise. So OpenShift Enterprise, we didn't really get into the metrics, the logging. There are some centralized logging capabilities in OpenShift, but we already had to look at that. What we also have are two online offerings. One is simply called OpenShift Online. And this is essentially OpenShift hosted in Amazon in a multi-tenanted environment where there's a free tier, but if you need additional compute resources or storage or what have you, then you can purchase, pull out your credit card and buy additional access to it. But it's a multi-tenanted environment running the OpenShift software. We also have something called OpenShift Dedicated, which is, kind of think of it as OpenShift Enterprise delivered as a service hosted in Amazon, managed by Red Hat, right? So if you want to start playing with OpenShift Enterprise and benefit from some of the capabilities that Josh showed you, you don't necessarily have to stand it up yourself. You can come to Red Hat and we'll give you an environment hosted on Amazon, on their cloud.
Or Google or Azure
Google,
as well.
I should say, yeah. Managed by Red Hat. It's not a multi-tenanted environment, right? It's dedicated to you. I spoke a bit about this earlier in terms of our middleware platform. This is very exciting. Once you have this tremendous tool like OpenShift or some other infrastructure for hosting containers, a very easy way to populate your service catalog with useful things is to take advantage of our middleware packaged up under this XPaaS umbrella. And by that I mean, for instance, if you're using JBoss EAP or the JBoss web server, which is essentially Tomcat, as you scale up the number of pods, like Josh showed you with the SketchPod demo there, it will auto-cluster those JBoss instances and replicate state across them. Similarly, if you're using something like JBoss Data Grid, it's not there, but Data Grid, it's the same thing. It'll replicate the data and shard the data as you increase the number of instances. Yeah.
I was going to say AMQ is a great example as well. It's a messaging broker. Our next major version is going to be able to replicate from one broker to another directly. You don't need shared storage necessarily or highly available storage behind it. And it's going to help make sure that there's anti-affinity of those nodes so that you can replicate messages and not lose data.
So this is all of our middleware really coming in an easy-to-use packaging that's ready to deploy on OpenShift across all those different infrastructures. Storage as well. So we have our Red Hat storage offerings in the format of the Ceph and Gluster technologies, and we have ways to we're providing plugins. So Kubernetes will leverage Ceph or Gluster as a persistent storage mechanism, but also we have the capability to kind of build this hyper-converged environment where your Gluster nodes are actually running as container images within the cluster itself. CloudForms we've mentioned a couple of times. When we launched OpenShift 3 in December, we announced that we're actually including CloudForms, our cloud management platform, with OpenShift. So when you buy OpenShift, you get it. CloudForms is the tool that's going to give you visibility into the entire infrastructure. As far as OpenStack integration is concerned, OpenShift and Kubernetes has plugins to support the various OpenStack providers like Neutron and for storage and Cinder for Neutron for networking and Cinder for storage on 52 nodes or something like that, and we've got 1,200 pods running, and there are a bunch of dashboards where we're collecting metrics and visualizing them for you, and giving you the ability to drill down, like I said earlier, from the individual container level to that container host, to potentially a VM that's supporting that, to potentially some underlying infrastructure that's supporting that, whether it's a RHEL host or a ESX or Amazon or so forth. Satellite has an interesting role in here. So hopefully many of you are familiar with Satellite Server. Satellite is a basically a management server for helping with the provisioning and management of bits traditionally within the operating system, right? So this is where you get new versions of RPMs for RHEL get hosted in satellite servers, then subscribe to various content views or channels within the satellites to remain up to date. And then we give admins a lot of control over how new versions of various packages are promoted through their staged environments. So in Satellite 6 in particular, we have the notion of these staged environments from the library, which is basically the dumping ground of all the stuff from upstream, like from RPMs from Red Hat, to however you want to define them. Maybe like a dev environment and a QA environment, and then a production environment. And the people who control those environments are the ones who say, okay, I'm going to promote this content from dev to QA and then QA to prod. And this has worked very well for RPMs, but now we've opened it up to new kinds of content. In particular, Satellite now acts as a Docker registry. So you can have a registry containing bits that maybe are fed out of your OpenShift registry or come from somewhere else. And then and maybe you have this wonderful automated CI/CD process for getting code to container in dev, but then you want to introduce a more structured manual process to promote that content out of dev into the upper level environments. And that's what Satellite will do. You can say, I'm going to take these registry contents and now make them available to prod, and then the hosts, the nodes in the prod environment will then have access to all the new registry contents there. Also, Satellite, based on its kind of hub and spoke model with the satellite and the capsules, handles replication of registry contents across infrastructure. So you can certainly build OpenShift clusters that span infrastructures, right? And you might want to have a satellite in your internal data center and then capsules out in Amazon or Google, and the servers out there will talk to those. So mirroring content is another important role that Satellite plays here. Pretty much to wrap things up, what we're doing at Red Hat is we're trying to make sure that people can benefit from the value that's and promise that containers provide across the entire set of our entire portfolio of product offerings across every single infrastructure that customers are interested in running their workloads on. And really, it doesn't matter whether it's physical or public cloud. And we can kind of provide that seamless, portable layer that you can imagine are a fabric for supporting containerized applications across all of your infrastructure. So that's it for the prepared content. I think John wanted to come upstairs and close things up for us here.
Let's give him a round of applause. Could you raise your hand if you consider yourself on the ops or infrastructure side of the house? And the others would be on the dev side of the house, app dev. Okay, very cool. Red Hat, who's known for Linux, now has over 30 products. And as DevOps is becoming popular and we're implementing that continuous integration, continuous deployment pipeline, we are moving upstream to the line of business and to the app dev space from being in engineering and operations. So what I want to express to everyone here is that Red Hat, when I started just 4 years ago, had about 4,000 employees. Today we've got over 8,000, and we're growing to 20,000. And a lot of those employees are in positions that can come out and help you with all of these products one-on-one. So don't be bashful about ringing up Red Hat's 800 number or our account exec, your solution architects, people within our professional services organization. It is really our aim to accelerate the community, and when I say the community, I mean the open source community, but our client community, to accelerate your adoption of these products. And we have a sense of urgency about it. FSI is at the tip of the spear in innovation. I was going to go into a little talk about the Uber moment, that banks are having their Uber moment. I don't know if you've heard that, but Anthony Jenkins, the former chief executive of Barclays, is saying that banking is undergoing its Uber moment.
And he's predicting that retail banking especially is going to cut the number of branches in half, reduced by as many as 800,000 employees because of the types of technologies that are being made available through these kinds of systems. So we have a sense of urgency about it. We have a sense of excitement about it. It's a very, very fast-moving pace of change type thing, and we want to improve your time to market and reduce your risk. Any other questions, comments?
With the focus here being, financial services and registry, do you see your customers in financial services moving towards Docker Hub as an option? No, right?
Like I said earlier, running stuff in Docker is essentially like running root on your host. And so, understanding the provenance of the bits that you're going to run on there and whether they come from a trusted source is important. So, no. So Docker Hub, it's a very interesting place to go and look, right? And if you have maybe some secure environment, maybe it's an interesting place for developers to play with. But definitely people are using internal staging environments where they can put trusted content into registries to be made available to developers.
So it is a great place to take a look at the Docker files, to get a recipe maybe, because
right.
I set up WebSphere, for example, by just finding someone else who'd already put it up there and creating my own version of that running on RHEL. I guess one very important note about containers is that we talked about the only integration or the only tie that needs API and API compliance is between that glibc as well as the kernel. And you want to make sure that whatever Linux distribution you're using in that container is going to remain compatible. So, long term, if you start using other distributions that are not really the best distributions, you might end up with some challenges between the system calls and that user space. So it is really important to make sure you're using some sort of certified version container to make sure that you don't have any incompatibilities later on.
So one of the things Red Hat is doing is we are in an alliance with Black Duck. We have an alliance with Sonatype and other scanning tools, and we're working to secure the container. So as you have repositories with different components that are being imaged into your Docker files, we have mechanisms for evaluating the vulnerabilities that exist and then applying remedies to those.
Well, there's a point I just mentioned right before, right? So you need this compatibility between the actual user space that you're deploying in the container as well as the kernel. There will be a need for possibly moving these OpenShift environments or container environments around. Virtualization still provides abstraction from the hardware. The containers don't necessarily provide that. So virtualization can provide value, but what you really want to avoid with virtualization is that bespoke VM that someone owns and they can put anything they want in. That's why containers are really disruptive. But virtualization still provides value in abstracting you from the hardware level, and also there's a huge ecosystem, for things like HPC with direct integration with networking stacks and everything else. They can still be very valuable, or you can still use it with other investments.
I would say the number one use, probably, in my opinion, of virtualization, still having a virtualization layer, is to provide high availability for stateful applications, where maybe you need to do maintenance on the underlying server. Well, if there's no virtualization, you can't migrate containers today, right? And so you have to shut those down. And if it's a ephemeral, cloud-native application, who cares? They're built that way. But if it's your Postgres database or something like that, you'd want to migrate those workloads off the host before you do any service.
So was this question?
We need the microphone for that one.
Yeah, I mean,
A bit of overhead with the VM.
of course. Yeah, there's no.
Can you repeat the question?
Yeah,
So-
was this why would you need containers? Why couldn't you just use virtualization?
No,
Or
the other
was
way.
it why would, if you're using containers, would you? Okay. Good. Okay.
Yeah.
I think they addressed that. And then what was your question?
It's just you're compounding one
They're
virtualization
additive
technology with another,
overheads.
so you're adding.
Yes, for sure.
Are you actually saying that if you wanted to aggregate your containers without the virtualization on bare metal, that you'd achieve?
I'm saying if you have if you're running bare metal hypervisor container, the overhead of the hypervisor is additive to the overhead of the containers technology.
What's the advantage of the hypervisor?
Like I said earlier, it gives you high availability in the case where you need to do maintenance on the underlying host, right? If you need to swap out some memory or do something like that, you can't live migrate containers off of that host unless there's a hypervisor layer.
Also, is it necessary for the infrastructure as a service to actually evacuate the servers and rebuild them?
Is it necessary for the?
Well, I think there's, a Kubernetes cluster, you might have separate sections of nodes that have certain aspects or properties, and to manage the size of those, and where they're placed and where they're on racks, virtualization technology is very mature at helping do that as well. But again, that is additional overhead. So if you're doing HPC workload, you're probably going to run bare metal. If you have a large PaaS environment, you're probably going to have multiple Kubernetes clusters, maybe for different sections. In that case, virtualization's got a lot of value in managing that at scale. But it should only matter, the virtualization should only matter to the operations teams, not to developers. Developers should just never see the virtualization aspect of it at all. And Scott McCarty here is our product manager for one of our products here.
So you said, like, why would I still use virtualization, right? That's kind of, so I'd expand upon it a little bit. I'd say, I like what Anthony said. At the end of the day, you still get some nice benefits like live migration, those kinds of things. But I'd even say more fundamentally, it's about exposition of resources and consumption of resources. So the containers consume the resources, and the virtualization layer exposes them. And you could expose those resources, by bringing a box in the room, plugging it in, putting it on the network, and then you've got X gigabytes of disk, X gigabytes of RAM. You get the gist, right? But you could also do it at a software-defined layer. So I think something like a virtualization layer still provides you a software-defined exposition of resources. So you're like, for example, in an OpenShift environment, I'll give you a use case. So if you've got a developer and they come into a self-service portal and they say, okay, I'm building an app that's made out of MySQL and WordPress, whatever, and I need 1 gigabyte for WordPress and 5 gigabytes for the MySQL container. And you need that on persistent storage. In a hardware environment, you'd literally still have to go file a ticket with the team that owns the hardware and literally get a LUN carved off that's 5 gigs and get a LUN that's carved off that 1 gig. If you do that on top of OpenStack, you can just get a 1 gig LUN from Cinder automatically software defined, and a 5 gig LUN automatically defined. So there's a software definition, a software defined exposition of resources is about the best way I could describe it. I'd say that's probably fundamentally one of the biggest reasons. The other reason I would say is tenancy. So I always talk about tenancy. If you think about a process being the least, the least amount of tenancy, really, like sometimes having 2 processes owned by different people running on the same server is okay. Not very often, but sometimes. I mean, we used to do that back in the day all the time. I'd log in back in college, and I could PS and see other people's processes, and nobody seemed to kill each other back then. And it was okay, but now obviously that's not the state of the art. But I'd also argue on the other end of the spectrum, you have, sometimes where, the same weather pattern, 2 data centers in the same weather pattern or the same, earthquake, region are not enough tenancy. I would argue if you're looking at processes kind of start at this end, then you go to containers, then you go to virtual machines, then you go to physical machines, then racks, then data centers, then, et cetera, et cetera. I'd say it's about tenancy and like where you want it essentially. So sometimes you still need a VM for tenancy, and sometimes isolated processes are not quite enough.
Well, we can adjourn. Thank you again for coming. Thank you for filling out your surveys, and
Good job, man.
please join us for refreshments.